Okay, let's start by introducing yourself and a little bit about your background.
Sure. So my name is Jen Bauer. I'm a geodata scientist at the National Energy Technology Laboratory, which sits under the U.S. Department of Energy. When I say geodata scientist, that's someone to me who blends together data science techniques with GIS techniques and geography techniques. So that's the type of research and projects that I support at NETL. So that can range from anything of looking at trends and patterns related to carbon sequestration, or the reason why I was brought here today was in relation to some of our transport modeling efforts for CO2. But we also have projects that are looking at understanding hazards that legacy fossil energy infrastructure like wells or pipelines could potentially pose for humans or for the environment. How do we mitigate and remediate or potentially prevent those things from happening in the first place?
Is that what you're delivering here at the conference, the presentation on all those things, or is that the more specific carbon capture aspects?
My presentation was more so on the pipeline routing planning database and the tool that's coming out for that from the lab. But I did have several colleagues here at the lab that were presenting on databases that have been built out to inform community benefits plans for looking at environmental justice or social justice metrics aligned to the Justice 40 initiative. We had a presentation on one of our mapping applications that's looking at critical minerals potential and resource potential across the U.S., as well as one that was talking about a national well database that the team is working on to pull in and scrape in public resources from the various state and tribal regulator administrations across the U.S. that collect wellbore information to kind of serve as a foundation for comparing and contrasting against field surveys that are going out that are trying to look and identify like undocumented orphan wells, or go out and plug and remediate marginal wells or the undocumented orphan wells.
All right, then let's, since you're here on the single project, let's focus on that. Can you get into more details of what that specific project is?
Yeah, so the CO2 pipeline routing database, or geodatabase, is really focused on creating that foundational level of information that you could use to inform when it comes to planning a route for a CO2 pipeline. So we know there's a lot of great data and information and authoritative resources out there, but they weren't necessarily integrated and available into one cost surface, if you want to call it that. It's not necessarily just economic costs, but also environmental costs. And then mostly in particular, there wasn't a lot of representation in previous work that accounted for a lot of the social or human justice metrics. So we wanted to make sure that as we built out a cost surface in this geodatabase that serves it, we were doing a good job of capturing and bringing in the economic potential costs, the environmental potential costs, as well as those human social costs.
And what are you hoping that this tool be used by, and for what purposes?
So the tools, the database as a whole, we're hoping is used by people that are looking at any kind of pipeline routing, whether they want to compare and contrast routes that they're looking at in terms of strategic design or understanding options that they might be having when it comes to different deviations of a route. We can help them identify what types of communities they might be engaging with or interacting with, what types of questions or potential impacts might be things to consider, whether it's looking at the structural integrity of the pipe itself. Are you dealing in high slope areas or areas where you're dealing with a lot of erosion potential from heavy rainfalls, or are you looking at wildfires, things like that. But then to also help understand, okay, if you're going through a community, what type of community might you be engaging with? Is this a community that is familiar with pipelines that have gone through their backyard before, or is this a community that really is new to the development process and would probably require and benefit from a lot of engagement to make sure that the pipeline wasn't being routed through any community valued property assets?
And all of those things you're describing, they're all inside this tool model. How long did it take you to gather all that information? That's a lot.
So the team, which is not just me, it's a team of about 6 people that have been working on it for 2 years now.
Okay, even things for legacy, so the type of pipe they can modify. How many different variables can they modify when they're trying to plan what they might do? Yeah,
so the database has more than 60 individual layers in it right now, everything from structures to high consequence areas to the regulatory buffers that are required for the setback distance to various pipeline routes or from other existing infrastructure. But we are hoping when it comes to using the tool, which is soon to come out, the tool itself that takes advantage of the database isn't quite out yet publicly. But that tool has kind of been simplified. So you put in a start and end location, or you can upload a route that maybe you've planned in a different software or something like Esri's products where you have a shapefile or a Geo-database output. You can upload that in. And it will basically run the cross analysis to identify what that route is interacting with. All the different 60 plus layers that we have, it will provide a report on what that looks like. Or if you really want to, being that our national lab has done a lot of work looking at CO2 storage potential, we do also have other information in there related to potential CO2 source sites, as well as information on the reservoir potential for storage, so that way people can maybe be a little more specific when they're trying to plan routes, make sure that they're starting at an area where they would be able to collect a lot of CO2 and ending in an area where it'd be safer for CO2 sequestration.
So for those pipeline developers, I assume that can they put their designs over your model, make it work together? Can they basically design from what you guys have built?
Yeah, people could definitely start designing off of what we started with. We know that certainly when you're getting into the more true engineering design metrics, there's a lot of things that go into those that I myself or the team are not necessarily experts in. So this tool is definitely meant to address a higher level need or a lot of decision maker needs, or to provide that starting point to get some of these additional variables that would be valuable once you go into the more detailed engineering design to make sure that are also part of that design process.
Oh, that sounds great. What were some of the maybe interesting things that you discovered along this journey with your team?
In terms of interesting things, we did a lot of work looking at the legislations that are in place across the U.S. in support or just available that speak towards pipeline development as a whole. So the team developed out a spatial layer that goes through the U.S. and identifies if legislation has been proposed or if there's active legislation on the books that deal to or speak to or might offer insights in terms of pipeline development, what can and cannot happen. So the team has done a lot of work and shed a lot of insights in terms of what you might assume, for instance, U.S. states that already have pipelines running through them, especially those existing ones that have CO2 pipelines. I would have expected a lot of them already had legislation, but some of them didn't necessarily. So this was a good way to kind of spotlight that while you might be familiar or comfortable with your local government or your state's regulations, this is a way to kind of highlight those deviations across the U.S. as well as how frequently they are changing as people are beginning to have more and more conversations about the potential for CO2 transport across the U.S.
It sounds like this would save those developers a huge amount of time to have to each one do their own research. How are you trying to approach them to let them know that you have this tool and that they don't need to reinvent the wheel?
So certainly we're trying to get the word out. Being that we're scientists, we're not always the best about communicating to every audience. So opportunities like this is a great way to make sure that we're reaching some of those more diverse audiences than the traditional scientific publication might. And while we have those mechanisms, and those are great ways at detailing all the work that went into, as well as helping people understand if they're going to take the data and use it for their planning efforts, they have a better understanding of what's contained and what's not contained. But we're always looking for opportunities to speak to trade journals or to engage through conferences that might hit a bigger, broader audience of users, as well as go to conferences that are targeting specifically the pipeline industry. So we have one up in Canada in September that we'll be attending as well and promoting.
Okay, so again, focusing on the carbon capture piece, but this is the entire pipeline network. Any pipeline could use this tool.
Yeah, there might be some certainly additional data sets that people might want to add to if they were looking at hydrogen pipelines, for instance, or natural gas or oil, whatever it might be. There's always specific kinds of questions or caveats or impacts that might need to be considered that are unique. But we're hoping that this serves as a good foundation of information that can really help with those efforts so that people aren't spending a lot of time maybe trying to find those additional layers. They know that they have a go-to source that is coming from those authoritative resources that they can hopefully start from.
Yeah, I mean, again, this seems very helpful. Why is the impetus to help these people? Is this, it's like a government to mandate it, I guess? They're trying to make it more efficient? What's the goal, I guess?
Yeah, the goal is to really provide information. That's our goal, is the more information that we can provide ahead of time so that as these routes are planned, hopefully they can be developed quicker. If you have a better understanding of some of the challenges or potential consequences of going option A versus option B, it can hopefully provide all the people that need to be involved in those decisions and in those choices more transparency on the decisions that are being made, and then hopefully make sure that as they're moving forward with the actual development, they have the support from the communities and the people that they would be engaging with, so that things don't get started and potentially fall apart, because we want to follow after CO2 and move towards our net zero goals. And to do that, having the ability to hopefully accelerate and eliminate some of those barriers that might slow things down is going to be, we think, very valuable.
As you make this tool available to people and they use it, do you then get feedback from them on things that they would like to see, and you keep adding and building?
Yeah, we definitely get feedback from our users, and we always welcome feedback from our users. We do sometimes have to work within the constraints of what our research budgets do or do not allow. So just like any tool development, we have to hear what people are interested in, prioritize. So we just had a meeting a couple weeks ago with some internal stakeholders, and they provided us some great feedback before the tool goes live, which should be sometime this summer. But because they had feedback and we needed to address it, it slowed down the process, because we were hoping to get it out before this conference. But we had a couple minor tweaks to the reporting process that we needed to make, just to make sure that we were formatting the report and providing information in the most useful manner to people. And I'm sure we'll continue to get more feedback on that, as well as additional functions that could be added to the tool that will hopefully make it more useful and continue to keep it in use as time goes on.
What are, I guess, some of the key people and things that, is there a group that you think might be able to use this as well, besides the pipeline industries? Or is this meant specifically for that kind of group?
So we are hoping eventually to expand it to look at other forms of transport. So intermodal transport, rail, water, road, whatever it might be. So certainly there's nothing at the moment that is particularly limiting us from looking at those other forms of transport, or people that are looking at those other forms of transport for moving CO2 or other forms of energy resources. So we're hoping that, again, this is a good foundational layer that people who might have a goal to, even if it's different from what we're looking at, can at least come to this as a starting point, decide what's of value to them, and carry it over to, again, reduce that kind of immediate burden of getting started.
You talk a research budget. How much of this is created from research versus utilizing data that already exists?
So a lot of this is building off of those authoritative data sets from other federal resources, as well as working within the federal guidelines from PHMSA and stuff like that, to make sure that as we're adding buffers or adding criteria that says, you cannot have a pipeline within so far of a high consequence school area or a nursing home, we're reflecting that in the database. So we are adding to those foundational layers that the other federal agencies are providing or state agencies are providing, to make sure that we're expanding it and making that information useful. So that's where the research budget comes in handy, for sure, to make sure that we're keeping it up to date, making sure that as new releases of information is pushed, we can use scripts and automatically update the database ourselves. But a lot of the R&D work is going into the route optimization problem and trying to see if there's ways that we can enhance the algorithms, essentially, that are planning these routes for people, to make sure that they are equally considering all the cost, but also the environmental and the human costs as well.
That sounds very sophisticated. How much autonomy do you have to go in these different directions versus you instructed on what people want you to find?
We definitely have the option, being research, to propose new directions. We always value buy-in from our stakeholders. We want to make sure that the things that we're developing, since we are a federal agency and our products are meant and designed to support the U.S. public as a whole, we want to make sure that we're trying to hear those voices and make the tools, the data, the information that we're providing as useful to as many people as possible.
Who do you consider the key stakeholders in this?
We've had a lot of engagement from people across the carbon capture and storage portfolio, whether that be companies, operators, people that are working in developing new technologies and looking for opportunities to connect to some of those stakeholders. It varies, but generally people that have an interest to carbon capture and storage at the moment.
Like as a personal level, how do you feel about the project's success so far?
I think the project has been very successful. We know that there are certainly other pipeline routing models out there or other algorithms that will do route optimization based off cost analyses. But we do feel like the tool, the database we're providing offers, a quicker starting place. So you're not starting from ground zero, you're starting several hundred feet ahead. And through that, we're getting really great feedback because there's a lot of need, I think, for decision support tools that allow you to compare and contrast different route options or different scenario options. And that's what this tool is really being designed for, is to help people compare and contrast the options in front of them and use their information and the insights the tool provides to make more informed decisions.
Oh, that sounds great. What about in the near future, some of the things you might want to tweak and improve?
Yeah, I think in terms of tweaking and improving, so after being at the Esri conference, we saw lots of tools that their software suite would allow us to build on quickly, so that if you planned a route, for instance, it would be really quick to understand, okay, out of those high consequence areas, how many of those areas are you immediately interacting with if you go with option A versus option B, or route A versus route B, or whatever like that. So we are hoping to leverage some of those tools to make it really clear up front, what is the difference between some of the route options that you might be looking at, get that most important information that different stakeholders and decision makers are looking for to help them better evaluate and decide, okay, well, let's really spend the time truly engineering or diving more into the true route design here versus looking at this first option that maybe we planned, and now that we look at some of the communities to be engaging with or some of the potential environmental consequences or additional costs it would take, maybe that's not really the way we want to go.
Okay, I can't imagine there's too many similar situations, but if someone was trying to develop a similar data set but in a different environment, what advice from your experience and your learnings might you pass on that they could help them maybe do it faster, skip a couple of the detours or the roadblocks that you ran into?
Yeah, I think for our team, some of the biggest roadblocks were just dealing with the complexity of the data and information that's needed at a national scale, not to mention the fact that the US has the challenge of having to cross through certain international borders to connect some states to each other potentially. So you might not always get the same level of detail or information provided when you're trying to cross some of those international boundaries. So being aware of the freedom of information across different states, across different country boundaries is always valuable, but also understanding the complexity and looking for ways, since all of this is going into machine learning models, you can really increase the cost of running and executing those models, not just in time, but actual dollars and cents cost if you're not doing a good job of trying to simplify some of those relationships now that still represent the data and information accurately, but might help reduce the complexity when it comes to the computational time load. A good example of that is just building footprints and the setback distances that you're required from buildings. We went ahead and simplified all of that into one layer versus the 11 million individual features that it could have been, and that has saved tremendously on processing time when it comes to doing the machine learning route optimization work.
So the machine learning, you brought that up. How specifically is that being used?
So the machine learning is using, right now, we looked at a couple different reinforcement learning strategies through machine learning to plan routes, and we're still figuring out which algorithm, or do we want to provide multiple algorithmic options for people to test. But essentially the goal is to build out a reinforcement learning model that can understand some of these costs or weights that come with different decisions it would make as it moves from point to point to point along the route, saying, okay, well, maybe you're not advised to cross a railroad or advised to cross a waterway, but there are certain steps that you can take to mitigate for that versus trying to go through or directly under a school. Schools aren't going to be allowed to go directly under. So we're trying to make sure that the model, as it's going through and planning these routes and evaluating as it takes every potential turn it could to connect from point A to point B, that it's really trying to make those types of decisions that we would expect that would align with the regulatory guidelines and requirements that we have to follow, but also take into some of those different metrics that maybe aren't necessarily represented in the regulations right now, like understanding the things that are important to a community, and potentially going through a burial ground or something like that might be more consequential than trying to maybe go a different route. So trying to make sure that those things are represented, even though they're not necessarily specific regulations that say you must not or you cannot.
This is fascinating. This could be very relatable to our audience. Is there anything before I stop recording that you feel like we want to add to the discussion?
The data and information, if people want to start working with the Geo-database in their own efforts, that is up and available on NATL's Energy Data Exchange right now, or EDX. The URL is https://edx.natl.doe.gov, and they can search for the CO2 pipeline routing Geo-database and get access to it.